Oh gosh. Okay, they're asking up with a lot of questions here. Let's see what the actual questions are. If they're quick, or if they showed an attempt, we can take a look. I'm not seeing a lot of attempting being done though. Oh, for 8. Okay. Oh gosh. No one responded to this part because it's a lot of work. I don't know if I want to respond to it either for the same reason, but at least it did something for 8 years, so let's check that out. I don't know if I'm gonna... These are pretty long questions here. 8, 9, 10, 11. At least 11 is short. 2 sections of a psychology class were taught by 2 different methods. Information on the students' final exam scores are used to determine if the results present evidence of a difference in the effectiveness of the 2 methods using alpha equals 0.01. For method A, the mean score is 85.17, standard deviation 9.14, n equals 12. It hurts me that they don't just use mu and sigma, but I'm not the boss of them, I guess. They do n's? Ugh, okay. For method B, the mean score is 80.85, the standard deviation was 8.52, and n was 13. Assume normal population for score values. Wait. Assume normal population for score values. And they tell you to use t-distribution? Is this supposed to be approximately normal? T-distribution. What are the conditions for this thing? Because maybe I just don't remember it well enough. Maybe the t-distribution has some condition to being approximately normal, but if they say just assume a normal distribution, why aren't you just using z? Because that's a normal distribution. It is a small sample size, I guess. It's not paired T because these are 2 different groups of students, not the same group of students twice. I just hate the phrasing of that. Okay, well we're given that we have to use T here, and what is an interesting psychology fact? Teachers who force students to write random interesting psychology facts on their homework probably need help. I don't know why I'm being mean today. Anyway. Method A versus method B, why is score value? Actually, I think X is method A, Y is method B. But this depends on how they were taught, I guess. I don't know. And then wouldn't then... Hey, Bob, how's it going? And then if we have X and Y up here, why aren't we saying our null is X equals Y and our alternative is X not equal Y? Wait, are these mu's or m's? Okay, that almost looked like or these 2 down here look like mu's for a second, while those look like m's, but I think these are just m's. Which I also don't like, but it's probably the way that they were just taught. Now, when you have a 2-sample t-test, do you simply add the n's and subtract 2 for your degrees of freedom? Let's see. 2-sample t-test. One variable defines the two groups, the second variable is a measurement of interest? I guess they did do that X and Y part right. I guess that makes sense. I don't know, I was never taught to do it that way. Oh. Oh my god, excuse me. I'm trying to figure out the degrees of freedom. Where are the degrees of freedom? Where? Why can't I never just find what I want when it comes to stats? Oh, I forgot. It's this horrible formula. Unless you have equal variances, but we're given the variances and they're not equal. 9.14 and 8.52. I wonder if they were taught to do that anyway, though, if they're close enough. Ah, man. And well, I think maybe not, because they say DF calculated and DF used in table, which makes me think that the DF calculated is going to be a crazy decimal like you would get from this fraction. And then you would round it down when you're actually looking at a t table. Alpha is 0.1. Hey, Cloud. Hey, Stookie. Hope you two are good. Right now I'm reviewing this stats problem that this one student is doing, and they seem to have been taught it in a very weird way where we're given the problem to assume normal population for score values for a two sample test, but then they start using t, even though I feel like if you assume a normal population, why aren't you just using z? But it's given in the sheet that you use t, so I guess it's just a phrasing thing. I should probably I should probably take a note that I want to ask them about their degrees of freedom, because I feel like that part is potentially off. For 8 degrees of freedom. Hey, FPS. How's it going? The variances are equal. We don't have equal variances here. Okay. So you see, they say standard deviation though. So I think it's either you have a big enough sample size, which we don't, or you know the population's standard deviation. Well, okay, yeah, I guess you're right. I assume, yeah, you're right. Okay. So I wish they used the symbols too, because if they used sigma versus s, that would have made it much clearer. I guess they use s down there. So maybe it's not too bad that they use that assumption that the population variances are equal. Calculus is ruining me. Oh, I'm sorry, FPS. Is there anything I can help you with? Please let me know. Your most favorite number? That's a good question, Claude. I don't really have that much of a favorite number. Like, I don't know. I mean, like, I feel like if you say 3 or if you say 7, unless you have a special story, you're just kind of like a follower because that's everyone's favorite number. Hey, Omar. So I definitely wouldn't want to choose one of those, but then, like, what do you choose? I could be a real hipster and say that, like, E is my favorite number. Yeah, you know, let's just go with E. It's a cool number. Number of people in chat right now? Oh, I might hit 6 actually, but I'll take 7. I'm not gonna complain. Actually, my favorite number is 90,001. Specifically, if there's a cloud in front of it. You hate prime numbers? I don't really hate problems that involve prime numbers, so I can see that. In your first year of math, you're quite demoralized. Oh, I'm sorry to hear that, Omar. What class are you in? Is there anything that I can help you with? Zero, that's a good favorite number. Okay, so in the meantime, let's look at their... I'm just gonna trust them on that Y1 bar, Y2 bar things. It's kind of weird for me to put it like that, but let's see. The formula for the t-score, this does assume the population variances are equal. I guess we're just going with that. You get 0.68, distribution tails. You have moments of discouragement during your studies. Oh yeah, Omar. For me, it tends to be at the beginning where I see how much work is going to be ahead of me and that I feel like I'm not going to get anything. But I have a tendency to just, if I don't get anything, I will just like pound my head against the wall studying for like weeks at a time until I do understand it. FPS, you'd appreciate if you could do a partial fraction decomposition of a cubic fraction function. So like partial fractions with 3 terms, I could definitely do something like that. Let me see if there's a good example on Paul's site, just so I don't have to think of numbers. I mean, I can think of numbers off my head too, but let's just see if there's an example here. But I'll actually do it out on the whiteboard. I just want to get an initial problem that... Here it is. I can't read. Okay, so like if we took, would this example 2 be a helpful one for you to see, FPS? Because you have a cubic in the bottom there. I think that's a quartic, that's a quintic. Actually, I guess which part of it? Hey, Zach. Or I guess FPS, like, do you just want to see, because this cubic isn't going to be that hard to factor. So I guess which part of it would you really want to see? Do you want to see the factoring part of doing this decomposition, or do you want to see the actual just partial fractions part? Because factoring a cubic can be kind of tricky, but this one shouldn't be that bad. And sorry, I know I just asked you like 3 different questions at once. So that's the best beard. They don't... The actual partial factoring part. Okay, so yeah, I'll just use this as our example then. You know, Bob, I feel like it's dangerous for me to say this because you're much higher rated than me, but maybe at some point we can play chess for the title of best beard on Twitch. but you're also like twice my rating, so I feel like that's not going to be a good contest. Let's go green. Save the Earth. And I'm going to drop off the integral part, assuming you don't need to see that part, but I certainly can follow through with the integration too if you want to see, if you want that. But if we're just concerned with the partial fractions part, 3x cubed plus 4x squared minus 4x. Okay, so first thing, let's figure out how to factor this denominator here, because for partial fractions, we need this to be factored. So the top will stay the same. I need to see all the terms here have an x, so let's bring the x out front. So we get x times 3x squared plus 4x minus 4. Oh, the color's blue, never mind. I'll rewrite that last part. I don't write the entire thing, but actually that's a lot darker too. So I think Zach, you made a good call anyway. This should actually, let me just rewrite the first part too then, because this is, I think it's been much easier to see, right? X squared plus 4 over 3x cubed plus 4x squared minus 4x equals, okay. She was just probably seen as our gap in integration skills. Ein Stuckey tends to discourage on coming around the midpoint, avoiding something or a bit earlier. Getting something usually gets you through, but at some point, discouraging. Yeah, so Omar, you're definitely not alone there. I think anyone who's studied math or really any hard subject has had a similar experience. Not to like diminish what you're feeling. I'm trying to say that you're not alone though. Okay, so continue with factoring this. We have a quadratic on the inside there, so it has to multiply to -12 and add to +4. X squared plus 4. We have x. We have a 3x and x. It multiplies to 12 and add to -12 and adds to +4. We need a 6 and a 2. We can get a 6 from 3 times 2. Ooh. Okay. Oh, that's not it. I think I need to flip my signs. Yeah, I need to flip my signs. Sorry, whenever there's a coefficient of not 1 there. Oh, that's not what I wanted to erase. My God. When there's a coefficient of 1, I have to do this like guess and check way. It's just the easiest way for me to do it at least. 3x squared plus 6x minus 2x is plus 4x. Minus 2 times plus 2 is minus 4. Okay, so that's good. Hey, Dan. No, Dan, I don't know if it, like, I want to figure out a better way to do it, but I have 2 cameras now, a webcam and my old iPhone cam. And this is a bit easier for me to like stay in frame, but I do realize it's awkward when I'm like working on the board like this, that you see me twice. I could hide my webcam when I do this, honestly, like that. It's fractal, yeah. I might need to get in the habit of just hiding my webcam because it is awkward for that part. But no, just actually last week I got a second cam. Okay, and I'm sorry FPS that I'm kind of like so I'm just like talking. I promise you I'll get through this problem. If you know basic, you can make shortcuts for, oh yeah, that's what I just did. So I have like controlled numpad 8 to toggle my webcam. Oh, thanks, Zach, about the chat. Me and Penn. Okay, no worries, Dan. I appreciate you. Okay, so now we have something we can partial fractions with because we have everything factored. So we know that this entire fraction must be equal to some sum of a over x plus b over 3x minus 2 plus c over x plus 2. We have no irreducible quadratics here, so we don't need to worry about anything that fancy or repeated terms. So this is just our partial fractions here. And by repeated terms, I mean like we don't have a squared or a cubed on the outside of any of these here. Okay, so there's a different way to do partial fractions that I can never remember. The way that I always do it is I multiply through by all of these denominators and I just work out the algebra from there. There is a faster method that I just cannot remember for the life of me. This way just comes much more naturally, but if you do see a different way to do it, that's why. But what I'm going to do is my way, where you multiply everything by x, or both sides by x, both sides by 3x minus 2, and both sides by x plus 2. So on this side, all that's going to happen is we end up with x squared plus 4. Then over here, the a gets multiplied by the x, by the 3x minus 2, and by the x plus 2. The x down here will cancel with the x that we're multiplying by. So we just have a times the other two denominators, 3x minus 2, times x plus 2. B times the other two denominators, plus b. So x plus 2, plus c times the other two denominators, x 3x minus 2. So I hope you're good with this so far, FPS. And now at this point, we have a whole mess of algebra to do with factoring this out. That's kind of the reality of doing partial fractions. So let's just dive into it. X squared plus 4 is still the same. I'm just going to multiply this all out and show the end result. So we have 3ax squared. We have, oh wait, we already know that 3x minus 2 times x plus 2 is that part in there. So I can actually cheat a little bit and just put a's in front of all this. Plus 4ax minus 4a, because we'd have to have the a multiplied back inside. Now over here we have plus bx squared plus 2bx. You're still with me? Okay, good. Now here we have plus 3cx squared. Let's say C3PO, but that's not right. Ugh. Minus 2cx. I think that's okay. So now comes the, well, actually, okay, no, let's do one more step to make the next step a bit clearer. I'm going to group the right side here by what x's they have. So the x squareds will all go together, the x's will go together, and that'll be a bit more clear why on the next step if you don't already see where I'm going. So we have 3ax squared first, then I'm going to put the bx squared over here by it. Bx squared, and we have a 3cx squared. Now let's look for x to the 1 terms, because that's all our x squared. So we have 4ax plus 2bx minus 2cx. Now all of our no x terms minus 4a. And that's it. Okay. And actually, I'll even do one more step here just to make it even more clear what I'm up to next. So I'm going to do, from all of these x squared terms, I'm going to factor out the x squared. And I'll put it in front. Well, no, let me put it at the end. So we have 3a plus b plus 3c times x squared, just those three terms with the x squared taken out. I'll do the same here with just the x. 4a plus 2b minus 2c x, and the 4a is still just 4a. Can you do the integral of cosine of ln x, futures trader? I can investigate it after this problem. I assume that's integration by parts. I might want to look that up first to make sure that it's possible. Oh, okay, FPS. Yeah, so yeah, there definitely is a shortcut for partial fractions. I just can never remember it for the life of me, and I hate memorizing arbitrary things. So I just do it this algebraic way because it's very easy for me to remember. And I know as long as I'm careful with like my multiplication, I know I won't like mess up the technique here. And so now comes the most important part of partial fractions, which is called equating coefficients. If we know x squared plus 4 is equal to all of this stuff, then it must be that everything in front of the x squared, 3a plus b plus 3c, adds to 1, the coefficient of this x squared. It must be that everything in front of the x here, 4a plus 2b minus 2c, equals 0, because we have an invisible minus or plus 0x there. And it must also be that minus 4a is equal to positive 4. So we're going to end up with a system of equations here, like two different cases for a cubic function, but you don't want to remember these. Yes, so with cubics, you can have irreducible quadratics, and you can have like squared terms, which I can quickly show you what the rules are there. Those, unfortunately, there's not a good way around memorizing those, as far as I know. So let me equate coefficients here and see what happens when the dust settles. So we have 3a plus b plus 3c equals 1. That's from this equals that. Then we'll do this equals 0. Four a plus 2b minus 2c equals 0. And finally, we have minus 4a equals 4. So there's one here that's much easier to work with than all the others, which is this last one. Here we just know that a equals -1, and where we can use this fact in the first two equations and make it a bit simpler. So let's plug it in. Let's plug a equals -1 into both these first two equations. This one turns into, I'm going to do some mental math here. 3 times -1 is -3. Add -3 to each side, or add 3 to each side, and you get b plus 3c equals 4. Same over here, 4 times -1 is -4. Add 4 to each side, and you get 2b minus 2c equals 4, I said? That's a dangerous, I'm doing mental math, but yeah, that's right. Now it's just two equations, two unknowns. We can solve with elimination or substitution. I'm going to do substitution here. Just seems a bit simpler in this case. I'm going to solve this for b in terms of c. b equals 4 minus 3c, and plug this in over here. I know I'm drawing a mess of arrows here, but I hope that you're comfortable with like a two equations and two unknowns problem. So now we get 8 minus 6c minus 2c equals 4. Subtract 8 from each side. What is this turning into? Minus 8c equals minus 4. So c equals positive 1/2. Now we can plug that in up here and get b equals 4 minus 3 times 1/2. 8 over 2 minus 3 is 5 over 2. So b is 5 over 2. Okay. We have all the values for our coefficients, or our a's, b's, and c's. We can plug them back in up here, and that's our partial fraction decomposition. We come over here. Oops, sorry, I bumped my camera. So we said a is -1, so let's plug it in over there. -1 over x. B is 5 over 2. I'm going to write the 5 on top, the 2 on the bottom. 3x minus 2. Plus c was 1/2, so I'm going to write the 1 on the top, the 2 on the bottom. That is our partial fraction decomposition for the example problem there. And let's check that with the Paul's online notes. A is -1, B is 1/2, C is 5/2? Heck yeah. So we got the same thing, and from there you just integrate and get a bunch of lns. So if that makes sense, FPS. For the 3 different cases for a cubic function, let's see if this site should say what they are. Okay, so yeah, and actually I'll link it to the site too because I absolutely adore this site. It gives really good explanations of everything calculus, as well as differential equations and some algebra and trig stuff. So when you have the normal terms on the bottom, like ax plus b, that's normally you just put a on top. If you have something like x plus 1 squared, like a power, then you have to do terms for each power from 1 up to whatever power you're given. So if you have like a cubed on the bottom, you have to do ax plus b squared plus ax plus b cubed. If you have an irreducible quadratic, like x squared plus 1, then you have to change around the numerator. Technically, you could do partial fractions with complex numbers in there too, I think, but usually that doesn't get taught. Could we have simplified the function by crossing out x plus 2? No, because that's a very good thing to watch out for, FPS. But x squared plus 4 does not factor like that. X squared plus 4 actually is not... Actually, I should look at this one. X squared plus 4 does not factor the way that you said. If it was x squared minus 4, then that's the difference of 2 squares. And you can absolutely do what you just said and avoid partial fractions. Well, you have simpler partial fractions, but yeah. Yeah, you if you can avoid partial fractions, get some cancellations, that's always preferable. Okay. Fact to be exactly, yeah, that'd be like x plus 2i, x minus 2i. Hey, Scorpra. And so futures trader, and let me know if you have anything else, FPS, or if you have more questions about that. Futures trader was asking about integrating cosine of ln x. I do want to make sure that's possible in elementary functions before I dive too deep into it. I don't think it's that hard of an integral from what I remember, but I make sure I'm not misremembering. Like, I think it's something I'll be able to figure out. Okay, yeah, so that's nothing too bad. And I assume we want to integrate by parts. Let me look at what Wolfram Alpha does first. Oh. I'm not doing that. I wonder if you have to do that, but... Double, okay, yeah, Zach, thank you. I was like, I think that's using complex variable stuff or something weird. But yeah, let's just integrate this by parts, because that's the way that most people know. That's the way that I know. So I'm going to erase all this. We don't need it anymore, but I guess there's always the VOD too. Actually, let me take down the webcam. I need to get in the habit of that, because that does look better. No worries, FPS. God dang, the blue is an arm workout to erase though, jeez. Yeah, Zach, just keep choosing the blue marker, and I think I'm gonna like get some serious arm muscle. uh, okay. Okay, I don't want to use green because that was lame. Let's just go to black. So futures traders asking us if we can do the integral of cosine of ln of x. Now, Wolfram Alpha did it some crazy way with some crazy formula that I don't know, but I'm pretty sure we can do this with integration by parts. So normally we do integration by parts. Like, this is just one composite function. So you can't do like u equals cosine, dv equals ln, or, you know, a lot of classes use different notations, but that my class use u and v. So what you do here is you remember that there's like an invisible 1 times cosine ln x, and you can do integration of parts with that 1 in the cosine of ln. And to make it useful, you always want to integrate the 1 and derive the other thing. So I'm going to set my u equal to cosine of ln of x, and my dv equal to dx. So then we derive the u. And the format of this gets taught differently in different classes, so don't worry if you're used to it a different way. That's just the way that I remember it. Cosine of ln of x, we got to do some chain ruling here. Ln of x is 1 over x. Cosine derives to minus sine, so let's put a minus in front. Sine of ln x. Okay. Dx. Now v we integrate. That 1 just integrates to x. Now the formula is u times v minus v times du. The integral of v times du. So x cosine ln x minus is plus. X times 1 over x actually cancels. So we just get integral sine ln x. Ah, okay, I see where this is going now with Zach's hint. The integration haiku. For integrating function 3 times partially. I do not have strength. So here, it looks like we haven't made any progress because now we have cosine, or sorry, now we have the integral of sine of ln x, and who knows what that is. But if we just take a leap of faith here and integrate this by parts again, it's actually going to work out because we can use an algebra trick. So let's do the same exact thing with integration by parts, but we have sine instead now. U equals sine of ln of x. dv is dx. du is 1 over x, no negative sign this sign, cosine ln x. V equals x. uv minus v du. X sine ln x minus v du. X's cancel. Cosine of ln of x dx. Okay. And actually we need this in front too. Forgot about that. X cosine ln x plus. Okay. So now it's like we still haven't made any progress because we got our original problem back. But there's actually a trick here because we have to remember that we have a left-hand side here. So this whole thing is equal to the integral of cosine of ln x. And so just like it's any other variable, we can add the integral of cosine of ln x to each side. So this one will go away, and that becomes 2 cosine ln x, and we just solve for the integral of cosine ln x like that. So we're going to add it to each side. We get 2 integral cosine ln x dx. I'm going to switch these around because I like to write sine first. It doesn't actually matter. And now just one more step to solve for the integral, and that's dividing each side by 2. So the integral of cosine of ln x dx is equal to 1/2 x sine ln x plus x, oops, 1/2 x cosine ln x technically plus c. See a futures trader. I hope that makes sense. Yeah, it's it's not a trick I would ever have thought of on my own if I hadn't seen it done for me in a calculus class. Yeah, thank you both for the good questions there. Unless there's anything else from chat, I'm going to go back to looking around on the internet for more math questions. Oh, I was working on the stats thing, wasn't I? That's right. Okay, well, I guess I'm working on the stats thing. So let me, let's actually make sure no one has responded. Okay, so no one responded yet, which I don't blame them for. Okay, so they're doing a two-sample t-test here. I both say hypotenuse. Their alternative hypothesis was not equals, which means it should be a two-tailed test. So let me actually jot a note down there. I'm going to delete this note because I don't think it actually applies. What's happening with our p-value here? 0.86. Let me, okay, I'm zooming out again. Oh, they don't do it. It's like the critical t-value way. 0.860, I guess is the critical t-value, is greater than, wait, yeah, 0.68, their calculated t-value. What did they fail to reject in this case? Oh, because they did it one-tailed. That might have messed it up. So if we want to find out the actual thing, their degrees of freedom was 23, their alpha is 0.01, their t-value is 0.68. Oh, yeah, there's a... This is better done on the calculator. Shit, this is kind of hard to... I guess these are the alpha values on top here, so 0.01. Oh, yeah, these are the critical T's. Okay. That's not right either, though. I definitely think we should fail to reject here. Is there a slightly different format? Oh, is that Carl Sagan, Scorpra? I didn't know that Trish had an emote. This is like the exact same table here, isn't it? Yeah, it is. T test calculator. Uh, Actually, I would need a two sample. I just want to make sure that I'm like doing this right, because I feel like I don't know what the plus D is, but I'm going to choose to ignore that. Wait, what? I have no idea what half that stuff means. Oh, they want raw. Oh my god, dude. Why can't there just be a normal? I need like Penn Center's like virtual calculator. I don't know why a website can't just do the same exact thing. Okay. So our sample mean 85.17. 85.1.17. Standard deviation 9.14. Sample size 12. $80.85. I'm not going to check all their I'm not going to check all their other problems on the sheet, but since they showed their attempt for 8, I'm going to check this one pretty thoroughly. The rest I'll just kind of read and see if I can give general hints. 8.52. That one was 13. 8. Calculate. So I guess either way, for one-tailed or a two-tailed, we would fail to reject here. Why did they get a different t value, though? Ooh, the t value should still be the same, right? This person got 0.68. Hmm. Let me try and manually calculate the t value just to make sure. They might have made a simple entry error, though. What was it 85.17, 80.85? 85.17 minus 80.85. Has to shave off his beard? Dude, that penalty's a little too high. I'm not shaving my beard. That's my money maker right there. That's the only reason people watch me. String chess for a month? Oh no. That's also a pretty high penalty. 8.52 over 13. Okay, so they did make an error in calculating their t-score too. Solve integration problems every stream. Oh god. Or have to learn stats? Yeah, which one would you hate more? I think I'd rather stream chess for a month than shave off my beard. Yeah, I'm saying, to me at least, stats is like integration is fun. Stats is just horrible. Oh no, I didn't mean to do that. I think there's anything I'd say on this one. Oh, no one got first. I didn't even realize that. Nearly an hour into the stream. Well, it's Jed's now. You snooze, you lose, everyone else. Get wrecked. There we go. Okay. I'm already getting sick of stats, and this person had like 3 more problems on the sheet, so I'm not going to look at all these thoroughly. If they're the same thing, then I'm just like, I'm not going to do this all for them. Let's get all the medals in Trackmania. Oh god, I never even played Trackmania before. Isn't it super hard? Oh wait, so here... Oh god, they're mixing their terminology. Mean score, just mean, standard deviation, S. God, I hate whoever made this worksheet. And what is assumed normal populations for Y? I'm your second most viewed stream in 2023. You know, it's the math or the beard. Yeah, you don't care. It can be both. There's no shame in that. Wow, I guess I'm just everyone's number 2. That's cool, I guess. Definitely not super sad about it. So, number 9 is really just the same type of problem. So let's see, if this is gonna be another 2-sample t-test, because if so, then distance formula / velocity. Acceleration problems to use that prop. Exactly, yeah. I really thought you're just gonna suggest I do even more like really annoying types of math like stats and partial fractions. Which if it's to help someone, I'm always down to do the annoying parts of math, but definitely not the ones that I do for fun. Brain volumes for a sample of 10 non-OC persons. I don't know what OC is. I don't think it's particularly important though. Oh, obsessive compulsive. I've seen Orange County, but I don't know why. I don't think that's it. Unless there's enough evidence to show the average sizes are statistically different. Seems like another 2-sample t-test. Key for 1 and 2 if needed. Same thing. What is key for 1 and 2 if needed? It seems like something particular to the teacher. Does an ultrasound use ultrasound waves? Is that a stupid answer? Sorry, I was distracted by like their bonus questions. I still don't understand why they're there, but they said they need help with 8, 9, 10, 11. So 9 and 10 are the same procedure as 8. 11 though is a bit different. Types of variables are each of these. Hair color is categorical because hair color isn't a number. Income is a number, so it's quantitative. Group size. Can you treat that as categorical? Is that one of those trick ones where even though it's numbers? No, I think you would still call it quantitative. Maybe there's some context where it'd be categorical. I would have to think it's gonna be quantitative though. And then religion would be categorical. Are you the very model of a modern major general? That reference is lost on me. Pirates of Penzance? I never heard of that, no. Same procedure for those. For 11, a quantitative, okay, yeah, variable. Okay, so how should I explain this? That involves numbers with some tricky exceptions. Maybe we'll just leave it at that for now. And the end of it. Brown, black, blonde, etc. It's categorical because... Okay. Let's post this. And please, no more stats. Didn't have an answer yet. Another did I do this worksheet, right? Ugh, okay. Let's just look at it anyway, though. A new infectious disease spreads slowly at the beginning of an epidemic. It spreads until a majority of the susceptible persons have been infected or vaccinated, then the epidemic slows down. I played enough Plague Inc. to know that that's a good strategy. Assume one wave of infection. If N of T is the total number of persons infected so far at the time T, sketch N of T. Yeah, I guess that seems okay for a sketch. They're very vague on how it's actually supposed to look, so I didn't get much more particular than this. Describe the concavity of the graph of N near the beginning and end of the epidemic. Concave up at the beginning, concave down towards the end. Yep, I agree with that. Give a news headline for the epidemic on the day that R has an inflection point. FDA approves breakthrough vaccine, but vaccine. Yeah. I think I agree with all those. I bought a bicycle last week, so happy. The bike came with a speedometer, but I concluded it was defective. I brought it to the shop saying yesterday I rode to Caryville 23 miles in 79 minutes, but I was responding to read above 15 miles per hour. Help me make my argument for a new speedometer using the mean value theorem. Okay. Let me look at the mean value theorem. I guess it's going to be your average speed. Like you take the slope between the two endpoints and compare that with the 15 miles per hour. Paul. That's Rolle's theorem. F is continuous on the closed interval AB. F is differentiable on the open interval AB. And there's a number C such that... Okay. That's how you do it. So, well, we don't really have a function though, do we? So we don't know how much we're speeding and slowing down by. Let's see what this person put though. If they went 23 miles in 79 minutes, oh, they're doing everything in hours? I guess that makes sense because you have to do 50 miles an hour. 17.74 miles per hour. So I agree with their logic, but they should be more explicit about how the mean value theorem comes into play here. In this case, the mean value theorem states there must be a number C such that the average speed over the entire time is equal to the instantaneous speed, and that never occurs. So we violated the mean value theorem. Sketch my bike ride, time on the horizontal axis, position distance on the vertical. What? The entire point is there isn't. Oh, wait. Am I doing this backwards? They had to have been going above 15 miles an hour. No, wait, I think I was doing it right. So we just made it a straight line. Okay, so if we did just go for a straight line, which would be the easiest, your slope would be 17.47, which is rise over run. Doesn't that have to be way steeper? Oh, well, oh, time in minutes. Oh, that's why it doesn't look quite right. It probably is right, but in 60 minutes they went 17. Okay, yeah, I guess that's right. Okay, so I agreed with their first sheet. Their second sheet could use a bit extra justification, I think. It's my thing here. Extra justification in my eyes. Say how it relates to the VT explicitly. That must occur as instantaneous. Yeah, okay, speed. Somewhere inside the interval. 17.47 mph. Violated. Okay. If you're drawing, but it also asks to point out where the value guaranteed. I can't spell today. I have to sound everything out. By the MVT occurs. Did the easiest thing, which I would also do, and just made a line with slope 17.47. 17.47 instantaneous speed. Okay. I think it's enough. I think everything needs to be said for this worksheet. Okay, so let's go over to learn math now, I think. So I don't think we're going to find much else in homework help. I feel this person on a deep level. Dude, these percent questions are so weird. The phrasing is so particular. 74% of our projects were delayed. We wanted to decrease the amount of delayed projects by 50%. For a decrease of 50%, I think you do just divide by 2. But when you have the 2% mixed in like that, it is really confusing. People have different interpretations. Different math. In this situation, I would say your first option is correct. Dividing by 2. you know, if instead of 74% of projects being delayed, we had, I don't want to do 74 out of 100, but I want to make this into a fraction because I think that makes it more obvious what's happening here. So instead of 74 out of 100, maybe just divide it by 2 and say 37 out of 50. It's more clear to me that next time they want only 37 divided by 2. I should be able to do that in my head, but I just don't trust my mental math right now. 18.5. $37%. And just so I'm more sure that I'm doing this right, 18.5 out of 50, 0.37. Good. Okay, so I hope this explanation helps the person. This stuff is harder than it should be. Sine 50 over cosine 40? The stars are kind of weird. Is that multiplication and this is actually an identity? Like a sum or a difference? Let's go to Wolfram and see if we can... If I do sine 50 times cosine 40, put it in... it's assuming degrees. Okay, so that's not. If we do division... Okay. And I think it's because cosine of 40 is equal to sine of 90 minus 40, which is sine of 50, and they cancel. It would be this identity right here. There's one new comment, but I don't actually see it. Because sine and cosine, or because sine, I'm going to say x is equal to cosine of, wait, sine, cosine of x is equal to sine of 90 minus x. Cosine of 40 is equal to sine of 90 minus 40, sine of 50. Then you just have sine of 50 over sine of 50 equals 1. Okay. Basic mixing. Ooh, are we going to some differential equations? I think we are. Also, I'm going to check their work here. Okay. Okay. Write down but do not solve an initial value problem for the following two mixing problems. A tank contains 100 gallons of water in which 20 ounces of salt is dissolved. Water with a concentration of 3 ounces per gallon flows in the tank at a rate of 5 gallons per minute. Water drains from the tank at the same rate. Okay. So let's zoom in and see the atoms. Oh, hey, actually, that's actually a nice zoom for once. I should have done that from the start. Normally it like zooms in so far I can see the individual atoms. Now I want to read the question because it's so much easier to read it now. Okay, so they start by getting C, which is concentration at time 0, which is 20 over 100 is 5, which is, wait. Oh, okay, they found gallons per ounces and they converted to ounces per gallons. That's fair enough, I guess. Either way, it's the right answer. V prime of volume. V prime of T is equal to 0 because water is draining as fast as it's entering. Okay. And V in volume of water, or the volume of a solution, times equals 0 is 100 gallons. And at any time, I think it's a V of T equals 100 there, honestly, but it's all the same. Okay, so yeah, they're finding the rate of salt in per minute. Five gallons per minute? That sounds like a ton of water. But their math is right. So the concentration is out times the rate of 5 gallons per minute. Okay, so I like that. Divided by V of T. So already, I'd say that they should replace the V of T with 100. 1B. Or wait, 1B, 1A. Looking down at 1B, now it's pure water that's flowing in. Everything else is the same. And that seems okay to me. I would have the same note. Let's look at a second image. Using only your physical intuition, find a simple particular solution to each of the mixing problems in the previous problems. You should be able to do both of these in your head. A simple particular solution. Now, the particular solution part is really confusing to me because this is in the context of differential equations where homogeneous and particular solutions exist. But I don't think they're talking about that type of particular solution. I think they're talking about any point that is part of the C function that we can use as initial values in the next part. That phrasing is really confusing, though. It's a particular meaning, and they seem to be using it in a different sense. You already found a natural, the most natural points to give for A and B with C of 0 equals 0.2 ounces per gallon. Okay, then let's check their work for 4 or 3, same thing. Solve the two initial value problems on the previous page. Wait, one says to make an initial value problem already. I don't get it. I might be misinterpreting though, because they already said to get interpreting though. 2 is freaking weird. I don't get 2. Let's just look at 3. So for A, okay, they make the VOD into 100 now. It's not the. I think they should have done it earlier still, but they still get the point. What's happening here? Oops. Sorry. My desk. Why are there parentheses like that? I don't think this is actually separable. It's just a non-homogeneous ordinary differential equation, linear. Oh, I get why there's parentheses. This is their integrating factor and they're multiplying through by it. Okay. They're actually doing the work of using an integrating factor rather than just using the formula like I do. Which actually, I don't, I do it like that so little that I should actually check this. Oh, it becomes the product rule. That's how the integrating factor works? Wow. I honestly, I was probably taught that, but I have never, that definitely did not stick in my head like that. So yeah, now when you integrate both sides, you get, that's just fundamental theorem of calculus. That seems okay. And then when they divide, okay. I think I like their work here. C of 0 is equal to 0.2, which is equal to 3 plus C, which seems okay. So yeah, C is minus 2.8. Okay, that seems perfect. And then for B, this actually is separable. They might still do it the same way though, which is completely fine. No, they do separate it. Okay, I like this answer too. Additional analysis with how the function behaves as t approaches infinity. It doesn't hurt either. I just wanted to mention Wolfram Alpha as a resource to verify your work. It can't check the setup of your equations, but it can make sure you solved the differential equations correctly. At least example of the first problem. Let's make that a link. I wanted to solve this. C prime of t fraction 15 minus 5 C of t over 100 with C of 0 equals to 0.2. Hopefully it interprets that last part right, the initial value. Oh, it does. Heck yeah. Okay, good. Okay. I think that those mixing problems are kind of fun.